Today we will talk about geographical information systems and mapping or geographical maps. So this is a visualization of geographical data. So what this presentation covers, we have an introduction of what is a geographical information systems, so the software options for those geographical systems, where they are applied, so what are the applications, as well as data being visualized in a form of a map. So data layers, spatial data types, and characteristics of the spatial data, as well as metadata. And finally, we discuss the data visualization principles for creating the best maps. Okay, so let's begin with introduction. Here we give a definition of the geographical information system. So the geographical information system is a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying spatial data. So this is the formal definition of the geographical information system. So it includes the displaying of the spatial data, as well as the analysis, the capturing and the storing of this data, and any manipulations or changes we would like to do to the data. So it has to do with spatial data. This means the geographical maps are maps of physical locations or spaces. So that's why it's called spatial data. The geographical information system is abbreviated as GIS. So you will see this abbreviation through the rest of the PowerPoint presentation. So it's a system. The system starts with the input data or the spatial data, and then the geographical feeds that into the geographical information system. which is essentially a software that creates maps or visualizations of the spatial data. After that, once we have loaded the spatial data and mapped it, we can perform analysis and work with visualization techniques for the best representation of this data and for creating the best maps. So the output of the system is a map, so a geographical map. Once the data is visualized in the form of map, we can do analysis on the data based on the visualization and create metadata, which is data about the data. There is descriptions of the data itself. The geographical information system recreates real-world spatial data So the geographical information system would recreate real-world spatial data as a digital themed data layers. For example, what these layers include are boundaries, socioeconomic data, data about rivers, lakes and water, so hydrology, as well as roads and infrastructure and transportations, and the land use and land cover. So if there are any agricultural fields, let's say with orchards or certain vegetables and produce that's being grown. So the layers are shown on the geographical information system, as like we can see here. We have the river is here. So hydrology is shown, boundaries, that is specific cities or countries or continents. We might have socio-economic information as certain country or city as well as the demographic information about the population that lives in these areas. Infrastructure, so we can see here streets, streets in between the buildings as well as a bridge. So those streets or roads and the bridge are used for transportation and vehicles. And then we see some lands that are in the corner here that are agricultural lands that are used for agricultural purpose or are covered. So these kind of layers are assembled in any combination and they may be overlaid. That is, one layer might overlap with another layer for analysis purposes. So let's say the boundary of a city or populated area includes the buildings as well as the roads and the infrastructure in between them. The rivers might be crossing over the roads, so that's why we have a bridge. The roads would be crossing over the rivers, right? That's why we have a bridge. But those are overlaying on each other. The river is underneath and the road is on the top. Demographic information might be overlaying the physical buildings and agricultural fields as well. So let's look at the layers here. Some layer examples here. We have one layer called customers that is overlaying with the parcels that might be overlaying with the streets. And the land usage. So this is a visualization of the layers that we mentioned. So these are the digital themed layers that we mentioned in the previous slide. So the overlaying of these would produce a map that looks like this. So certain geographical areas along with the streets and parcels, customers, and land usage would render a map that looks like this. So let's look at some software that would create the geographical information systems. So types of mapping software. We will look at the type, the data analysis that it's able to perform, and we give some examples. The first type of software is the Geo browser. So it's just a browser, so it is used just to look at the maps. For that reason, its visualization power is weak. Data analysis power is weak because it's not intended to do analysis, but it is mostly just for displaying the data. For example, Google Maps. It might provide us guidance and directions through GPS, but it is not intended to do any analysis on the data that was used to create this map. So Google Maps, Apple Maps, Google Earth, and so forth are geo browsers. Okay, so web-based software. Its data analysis power is medium. So this software is able to upload additional data and to customize the display, as well as to perform basic analysis. The example software is Carto. So these are online softwares, so you can search for them on the web. ArcGIS, Mapbox, and so on. My Maps from Google. And third type of software is the desktop software. Its data analysis power is strong. it would need to be installed on a local machine. So that's why it's called desktop. Its data analysis power is strong, as it provides a full control over the map creation, and it can perform advanced analysis. The example software is called ArcGIS Professional, or the QGIS. Let me see if I can change the color of this, as it is not very well visible. Alright, so let's look at which desktop software we can choose and what are the features that it provides. So if we do a comparison between the ArcGIS Pro, which is provided by the company ESRI, and the QGIS. So the first one is commercial software for geographical information systems. Its price is high. It can only run on a Windows operating system. It takes a lot of space, so it requires quite a bit of computer resources, as the hard drive space and CPU processing time. However, it provides the full set of geographical information system functions and tools. It can be integrated with the online software, ArcGIS Online. It has a training program on how to use it. So it has online modules, written tutorials, and an online course, as well as support professionals. So if we require help, we can easily open a support case to obtain the necessary guidance. So in comparison, ArcGIS Professional with the QGIS. The QGIS is a free open source tool, so that is its advantage. It runs on any operating system. It doesn't take too much hardware space comparison to the ArcGIS. It has many data analysis tools, although in comparison with the ArcGIS, it would be lacking primarily tools for network analysis, such as routing network packets and tracking network paths, as well as spatial statistics. It has basic tutorials, that is, trainings on how to use it by the developers of the provided by the developers of the software. Since it is open source, anyone can any developers, computer programmers can contribute to the software and do contribute to the software on regular basis. Support is available via forums. So in comparison, the ArcGIS Pro is more of a professional software that has all the necessary support and available tools. The QGIS is a free open source tool that is more versatile as it runs in multiple operating systems and takes less hard drive space and resources to run it. So let's look at some geographical information system images. This here is an image of a city that has the transportation infrastructure as well as the water hydro resources. So there's a river and a lake here. 3-dimensional models can be created by analyzing this kind of imagery with a 3-dimensional software. We can show the buildings in 3D space or any relief of the geography, that is mountains and hills that are higher elevation than the sea level, and valleys would be shown in 3D as the natural elevation is. here's a map that shows some geographic information as well as socioeconomic information. So this one is showing United States population that has an Irish ancestors. This is an edit geometry tool that comes with the GIS professional software, and we can learn about these tools in the workshops for this GIS professional. We can also use a tool for analyzing values of the maps. This is called spatial statistics. And we can collect, create and load our own data. So the buffer tool allows us to load the data in real time. So these kind of maps are intuitive, as most of us have seen or used this kind of maps, for example with Google Maps or with Apple Maps or with vehicle navigation. This is the classical spatial map of populated areas, cities, towns and countries. So this is showing the infrastructure, the roads, as well as the hydrostructure, the river, and any overlaps to where the roads or bridges would go over the rivers. And then the green portions are showing either parks or agricultural fields where the lands are used for growing produce, orchards or vegetables. So bodies of water are one layer, the streets and the roads are another layer, the parks and the green spaces are a third layer. So several layers are used in order to create this map. Others are points of interest, for example museums, as well as labels such as stops of public transportation. So, what kind of spatial data types exist? There are several data types, geospatial data types. The coordinate data from the real world can be represented as a vector. That is, it can be represented with points, lines and polygons, such as what we have on this picture here. This is called a vector data. Or it can be represented as a raster. The raster would have rows and columns and looks like a matrix. This is common with the maps that we are used to seeing, such as these. They are typically divided by rasters. Each part of this map would have a specific square with longitude and latitude that's part of a raster, so we can tell the exact location of what part of the map we are either located at or interested in analyzing. So the vector uses lines and points as well as polygons, while the raster uses rows and columns and creates a matrix composed of pixels. So the points would look like this. These could be representing certain paths. Lines would represent roads and rivers. Polygons would show specific areas like city, county, or a green park or an agricultural field. And then we have the combined version that has all of these, the points, the lines, and the polygons on over here. So that is all that we have for the geographical information systems and maps for today's subject.